Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone. Welcome to this React Native course. My name is Arthur Callahan, and I work with Mammoth Interactive. So the name of this course is Introduction to React Native. To begin, we'll be going through the basics of React Native, and afterwards we'll move on to some of the more advanced aspects of React Native. So, React Native is a framework which was created by Facebook. It started in 2013 as an internal project within Facebook, and it eventually became so popular that React Native was officially released to the public in 2015. It's a beautiful framework to work with because it provides a convenient way to develop mobile applications. The two main mobile platforms, Android and iOS, both traditionally have completely separate development tools and tool sets to be used when developing applications for either of these platforms. And this makes learning to develop software on these platforms very difficult and time-consuming because, essentially, the same software would need to be developed twice, once for each of the main platforms. And this becomes an even bigger problem when we consider, for example, if a client is spending money and time to have an app developed for their business, that client has to spend double the money just to get that app to be functional across both platforms. And so, this situation gave birth to React Native, which is very flexible and is able to have one code base, which allows for applications to be created and run on multiple platforms or operating systems. So there are libraries available in React Native which you can use to create web applications, Android apps, and iOS apps as well. All of these features make React Native a very good framework. It allows for the saving of costs, time, and effort, and it is based on JavaScript language, so it's relatively easy to learn. Now, throughout this course, some of the things we will be going over are the architecture of React Native, some basic concepts. We will discuss what the different components of React Native are, how we can set up the layout, how we should structure the apps, and how we can break down the app into different components. And we'll also see how we can debug the app and the various tools that are provided for the debugging process. Now, this course is taught by Ashani Kumar and is narrated by myself, Arthur Callahan. Ashani Kumar works with Mammoth Interactive. He has around 20 years of IT experience working in various technology-based spaces within that period of time. For the last 4 years, he has been working on React Native and Android, where he has been building multiple mobile applications. Now, this course has been designed with beginners in mind and aims to help those who are starting out with React Native. But it also caters to more experienced developers, and as we go through the course, there will be some good takeaways which experienced developers will find useful as well. The concepts within this course are explained in a very simple, very clear and concise way. It gives an overview of the topic and then touches on the why, the how, and the what of the topic at hand. It then jumps to the coding aspects to show how we can actually code whatever we're working on, and how that will work on Android and iOS applications. So this course is simple and easy to understand. If you develop along with what I'm saying and with what you see displayed on the screen while you're watching the course, that'll be very helpful as well, and you should find that it's very easy to learn React Native. The course requirements are that you should have some programming experience, and you should have a basic knowledge of JavaScript. React Native, as I said earlier, is based on the JavaScript language and uses JavaScript as its coding language. Also, if you want to write some native code, which you are not going to be able to do inside React Native, you may have to write the native code in Android, Java, or iOS. We won't be going into too much detail regarding all that in this course, but we will be dealing with the entire React Native framework. So I hope you'll enjoy this course. It will definitely be helpful for you to learn how to build some brilliant mobile applications in React Native. That brings us to the end of this introduction video. Thank you very much for watching. I hope you got something useful out of it and will continue to get useful things out of this course. So thank you very much, and I will see you in the next video. Hello everyone. Welcome back to this React Native course. In this section, we will be going through and understanding how the React Native framework works. So we'll discuss what React Native is, how and why it came to exist, and we will have a look at the architecture of React Native. Furthermore, React Native provides the user with some tools. We'll have a look at what those tools are and what the best and most useful aspects of those various tools provide. Then, we will build our very first React Native app, and we will run this app first on the Android simulator and then on the iOS simulator. At the end of this section, I'll give a summary of what we've covered so far, and then I'll give you a challenge which you can do after this section or after you have completed this course, whichever you prefer. So thank you very much, and I will see you in the following videos. Hello everyone. In this video, I'm going to give you a brief overview of what React Native is and the kind of things that it can do. So before React Native came into the picture, developers were using different languages to create mobile applications for different platforms. So for example, Java for Android and the Swift or Object-C languages for iOS. Now, the use of these multiple and separate languages for different platforms became somewhat complicated. So there was a need for creating or writing the mobile applications for both platforms using one uniform language. And this is where React Native came into the picture. So simply put, React Native is an open source framework for building mobile applications on both the Android and iOS platforms. It was officially launched by Facebook in the year 2015. It actually started as an internal Facebook project in 2013, and because of its popularity, Facebook decided to officially launch it in 2015. It's a very simple application technology to use and to learn. It's based on the JavaScript language. Also, it uses React UI libraries and the platform-specific capabilities as well. Now, before React Native was available, software developers would use HTML to code, and every time they would have to create an HTML page or a web page, they would have to create the UI components from scratch. So Facebook launched the React framework so that the UI is pre-built, and the developer just has to import the UI library and create a UI component, and this made the life of a developer much, much easier. React Native also works on the same principle. It uses React UI libraries, and there are some platform native capabilities which can be used in the React Native application. Another interesting thing to note is that some libraries used by React Native come directly from React Native, and there are some other libraries which come from the React Native community. This means that if there is something which is not working correctly, or has some kind of performance issue, or is no longer supported, the developer can write that functionality in the native language of the operating system, which, for example, on Android is Java, and for iOS would be in Swift or Object-C. And then that native piece of code can be linked with React Native to provide that functionality. So one of the best things about React Native is that it has a single code base, which means that you just write at one place or in one language, and then you compile and create different platform codes. So it's extremely easy to create for both Android and also for iOS. Hello everyone, welcome back. In this video, we'll talk about how React Native works. This video will have two sections. In the first section, we'll talk about the coding process, and the code we use to create mobile applications. And in the second section, we'll talk about the inner workings of React Native mobile applications. So JavaScript code, which is kind of a set of classes and functions, can be created using just about any text editor. Now, there are some very sophisticated editing tools available online, but the basic point is that any text editor is sufficient to create JavaScript code. We will go into more depth regarding classes and functions a little later on, but just to give you a brief overview, a class has constructors and methods and functions. A plain simple JavaScript function has properties and a written value. So generally, we'll write the different classes and functions from scratch, but occasionally we'll also import React libraries and other libraries. So for example, let's say we want to use a camera. Now, camera functionality doesn't come built into the React Native core components. So in order to use a camera in React Native, we'll have to use a component provided by the community. So if we build our JavaScript code, there are times that there's a functionality which is not available in the official libraries, the official React Native libraries, or the community libraries. So that code or functionality would have to be written in a native code, such as Java for Android or Swift or Object-C for Xcode. So we generated a native code which goes straight in the Android project or the Xcode project. So we have two sets of files now. One is Java code, which allows you to have multiple files, and you have a native code, which is written using either Android Studio or Xcode. From here, we run the React Native build command, and you can do that using either the command prompt, or you can actually go to Android Studio or Xcode to build the project. Once you've done that, if you're building an Android app from the command prompt or Android Studio, you'll see an Android app, or you'll see an iOS app if you're building the app using Xcode or from the command prompt. Now, these apps you've just built are actually ready to run on mobile devices. The Android app is generated as an APK file, which you can easily install on any Android device. All you'd have to do is move the APK file to that device, and then it's ready to install and ready to use. But for iOS, the process isn't quite as simple. There's a few more steps involved. You have to create some certificates and generate the IPA file for ad hoc testing, and then you can install it on the Apple device. So that is a basic overview of how we write the different codes and create Android or iOS apps using React Native. Now, it is important to understand how the code, which is written in JavaScript, gets converted into Android components and iOS components. So let's go through an example. Now here, we have a component which includes the words view and text. Inside the text component, we have written the word hello in JavaScript. Now, view, as we can see written here, is a container, and it has a text tag. So when this code is exported as an app and used on a mobile device, it will display the text hello on that device. On Android systems, the component which is equivalent to JavaScript view is called view group, and the component which is equivalent to the text of JavaScript is text view on Android. Similarly, for iOS, view is equivalent to UI view, and text is equivalent to UI text view. Simply put, all components which exist in JavaScript have corresponding or equivalent components in both Android and iOS. Now let's discuss the architecture of React Native, basically how React Native works internally. Let's imagine that a user has an Android phone and a React Native mobile application is running on this phone. The user is interacting with the UI thread of the React Native mobile application. The UI thread talks to the native UI and the native modules. The native modules give certain functionalities, like Bluetooth or the phone camera. There is a second thread running, which is called a shadow thread. It's basically a yoga Facebook layout engine. It translates or creates a layout for the application. Additionally, there is a third thread running, which is a JavaScript thread. Now, whatever code that we write using JavaScript and other libraries, that gets converted into a JS bundle. And the bundle runs inside the JavaScript thread. Now, whenever the user presses a button or does any interaction with the application, that action gets transformed into a JSON serialized object, and through the bridge, it passes to the JavaScript thread. The JavaScript thread knows what has to be done whenever a button is pressed. For example, when a component color has to be changed or an image has to be replaced, it passes that information in the form of a JSON serialized object through the bridge to the UI thread, and then the UI thread presents that information to the user. So this way, the UI thread and the JavaScript thread talk to each other, they communicate. Now, this is the current architecture. The React Native team of Facebook is working on a new architecture, and roughly by the end of this year, that new architecture should be available. So you'll see that in this architecture, the bridge is a bottleneck. Something else which is important to note, the communication between the UI and the JSON thread is happening asynchronous. So a bridge is a bottleneck. Every time the user interacts with the application, the information has to be sent to the JavaScript thread, which then passes that information back to the UI thread. So there are a lot of messages flowing through the bridge at any given time. One of the changes the developers are working on with the new architecture is to replace this bridge so that the performance increases and there will no longer be a bottleneck due to this bridge. So this brings us to the end of this video. In the next video, we'll talk about the different tools provided by React Native to create the mobile application. I hope you enjoyed this video and got some useful information out of it. Thanks again for watching, and I will see you in the next video. Take care. Hello everyone. Welcome back to this React Native course. In this video, we'll talk about the two sets of tools that are provided by React Native for developing mobile applications. One of these tool sets is called Expo, and the other is called React Native CLI. CLI stands for Command Line Interface. Now, despite being different and separate tools, there's actually no difference in the way the user codes to develop apps with these tools. The coding process is the same across both tool sets. However, there are some basic differences between Expo and CLI. Firstly, Expo is a third-party tool, whereas CLI has been developed by the official React Native team and community. Expo lets you develop and test the applications faster, whereas for CLI you have to follow more steps in order to install, test the application, run the application, etc. Now with Expo, you don't need to have certain tools pre-installed before you can preview the application. So you don't need Android Studio, Xcode, or MacBook. None of these are necessary whether you're developing for Apple devices or Android devices. Whereas with CLI, you need these tools. Now you'll need Android Studio if you are writing in native code, and you would need Xcode if you are writing for an Apple application. But with Expo, you can just use a simple editor, any editor, and you can build your application and run it. So that's one of the very useful features of Expo. Now where CLI shines is that you can connect with the native Java or native iOS code, whereas Expo cannot do that. So for example, there is a functionality which is not present in any React Native library. So what we do is that we write a native Java code or a native iOS code using Swift or Objective-C language. And then we will add a bridge, and then we connect it with the JavaScript programs that we have written, and then we connect that with the native code. And all of this can only be done in CLI. We cannot do this if we are using Expo. Another disadvantage with Expo is that because it's a third-party tool, updates are more infrequent and they may get delayed, and they are generally less predictable and consistent. Whereas CLI is coming directly from the React Native team, so it's kept up to date with a lot more frequency and consistency. Android and iOS softwares are updated very frequently, new features are often added, or bugs from previous versions are fixed, and React Native follows these latest versions and ensures that everything is compatible and working correctly with these new updated versions, whereas Expo might not be as quick to get an update and make these necessary compatibility changes. Now, all of this isn't to say that Expo updates are guaranteed to be slow and not come quickly. However, they're not always as consistent as the dedicated React Native community updates. Now, one very useful feature of React Native development is that you can get out of Expo at any stage during the development and start working with CLI, and this is a process called eject. So this brings us to the end of this tool's comparison. In the next video, we'll discuss how to build our first React Native mobile application. So thank you very much for watching this video. Again, I hope you found it useful, and I'll see you in the next video. Thanks for watching. Take care. Hello everyone, welcome back. In this video, we'll be talking about how to build our first React Native application. So the URL which I'm showing here links to the official React Native website, and there it explains how to set up the environment used to start building mobile applications. So let's quickly have a look at that. So on this page, they have explained the different steps that you need to take if you're using Expo, CLI, or React Native CLI, and there are different steps which need to be taken for different operating systems. So if you're using Windows, or MacBook, or Linux, there will be different steps that you have to follow. For the purposes of this tutorial, I have already completed the necessary steps on my laptop, so I am ready to create my first project. This is my project folder where I have organized all my different recommended projects. To create the new project, the command that I have to write is this: React-native init and the project name. Init means initialize, so altogether it's React Native initialize my project. I press enter and it starts building. What it's doing right now is bringing the important libraries, the core libraries, which are required in the React Native project, and it's putting them into our project folder. It runs various other scripts in order to build our project. This process usually takes a few moments, and then our project will be ready. So now it has successfully finished the build process. Let's look at the core folder. So cd, my new proj, if I do ls, it will show us the default files of the projects and the folders that React Native creates when we run our init command. Now you'll see that it has an Android folder and an iOS folder and some other files. Now this Android folder actually contains the native Android project, and similarly, the iOS folder contains the native iOS project. There are also some other files as well. We'll look into these files in our next few videos. So this brings us to the end of this video. In the next video, we'll have a look at how we can run our new project on the Android simulator. So I hope you enjoyed this video. Thank you very much, and I'll see you in the next one. Take care. Hello everyone, welcome back. In this video, we will discuss how to run our React Native app on the Android simulator. So let's go to the command prompt. Firstly, we have to be inside our project folder. So I'm inside my new project, which I created in the previous video. So the command for running it is react-native space run Android. So it starts the program. It tries to find the simulator first, and now it has launched the Android simulator. So this Android simulator is part of Android Studio, so you'll have to install Android Studio first, otherwise you won't have access to this tool. Once it has launched, it is now trying to install the app. The first time it launches, it usually takes a little longer, but from the next time onwards, it's generally pretty quick. If you delete the app from the simulator and try and install it again, it will consider it the first time and it will take longer again. Now let's look at another thing. This is the Metro server. Every time when we build our app, the Metro server runs. So let's wait and watch. So it has successfully installed the app on the Android simulator. This is a basic page, one page that comes with the app when you create it. We have just a step 1 and then some other text, hard-coded text. And that brings us to the end of this video. In the next video, we'll see how we can install the app and run it on the iOS simulator. Hope you enjoyed this video, and thank you for watching. See you next time. Hello everyone, welcome back. In this video, we'll see how we can run the React Native app on our iOS simulator. So I'll start the app on the simulator from the command prompt. Currently, I'm inside the project, and these are the directory listings. So I'll start the app with the command react-native and run-iOS. So for Android, we said React Native run Android, and for iOS, we say run iOS. So when I press enter, it will look for the Apple simulator, and then it brings up that simulator. And then the simulator will install the app on the simulator and run it. Again, the first time we go through this process, it will take a little time, so let's wait and watch. So this is the Metro server running. Every time we run the app in the development mode, it brings up the Metro server. Right now, we can see that it is installing the app on the iOS simulator. Great. Now it has successfully installed the app on the iOS simulator. You can see that it's the same basic welcome screen which we saw on the Android simulator, this default screen which has a welcome message and some steps and text that you can follow. So this brings us to the end of the section. In the next video, we'll summarize everything we've learned in this section and I'll share one challenge with you which you can try. Thanks for watching. Hope you enjoyed it and learned something useful. See you in the next one. Hello everyone, welcome back. This is the last video of this section on how React Native works. So in this video, I'll summarize everything we have learned in this section. So we started by discussing what React Native is. It's the open source framework developed by Facebook and launched in 2015. We discussed the inner workings of React Native. We discussed the 3 threads, the JavaScript thread, the shadow thread, and the UI thread, and how the UI thread interacts with the JavaScript thread using a bridge. It relays the serialized JSON objects to pass the information back and forth. Then we had a look at the 2 development tools provided by React Native. One was Expo, which is a third-party toolset, and the other is React Native CLI, which comes with React Native and is developed by the React Native team and the React Native community. Then we built our React Native app using the command react native init and the project name. We then tried to run the app first on the Android simulator and then on the iOS simulator. Now, the small challenge I want to present to you is for you to set up the React Native environment. It can be a bit tricky, so I recommend you closely follow the steps and the guide found on the React Native website. Make sure that you identify your correct CLI, which you want to go for, and your operating system. And then follow the steps one by one, and you should be able to prepare the React Native environment. After you have set up the environment, you can create your first project and run it on the Android and iOS simulators. I hope you enjoyed these videos and the section and you got some useful information out of it. I will see you in the following sections and the following videos. Thank you for watching. Hello everyone, welcome back. In this section, we'll talk about how we can build our first React Native application. So we'll go through a few different topics. We'll talk about how to work with the React Native components, how we can set up a new project. When we're creating an app, it's important that we plan the process. We'll talk about all the things that will go inside the app, so what the main components are, the important components, and of course, what purpose we are building the application for. To do this, we will work with the core components of React Native. And at the end of the section, I will summarize everything we've discussed, and again, I will share a challenge with you. So thanks for watching. I'll see you in the next video where we will begin working in this section. Hello everyone, welcome back. In this video, we'll talk about the different components that we can use to build our React Native mobile application. Firstly, we will talk about the built-in core components. The basic components that come with the React Native installation are Vue. Vue is a kind of container where we can display text, images, and other components. We have text components, which can be used to display our text, image to display our image. Text input is to get input from the user. Scroll view, so if we have a long list that we want to show the user, we can show this list inside a scroll view so the user can scroll and see all of the list. Then we have a component called style sheet to style our components. The next set is the user interface. For example, a button or a switch, which renders a Boolean input. Then we have list views, flat list, and section list. We also have a scroll view, which displays a long list, and the user can scroll through that list. But if we compare the performance, the flat list and the section list are much better than the scroll view, so it is advisable to use one of those when we have a long list. Now, something to note is that there are components here which are specific to the iOS. For example, the action list. It's an APA to display an iOS action sheet or share the sheet. Similarly, we have Android-specific components, for example, backhandler, and these are only available for Android. The backhandler controls what happens when the user presses the back button. Next, we have the drawer layout Android, which renders a drawer layout on Android. Then we have the permissions Android component, and what this does is that if we have a camera in the application or a location we have to track, we have to ask the user for permission to allow the use of the camera or the location. So to display the permissions, we have the permission Android object inside the Android-specific components. Then we have Toast Android to display our toast alert to the user. Then there are a long list of other components, for example, alert to show an alert, activity indicator. So let's say if you're fetching a lot of data using a REST API from the database, you can use the activity indicator to show the user that there is indeed some activity going on. If you've ever seen that circle that keeps rotating while something is loading, that's an activity indicator, and you might be quite familiar with that one. It exists to let the user know that the app is actually processing something and it hasn't just frozen. Then there is animated component used for animations. The dimensions component is used to calculate the dimensions of the phone. So mobile phones come in different dimensions. Some are small, some are big. And for this reason, it's not advisable to hard code the width and the height of the screen size when you're developing an app. So we can use the dimension component to find out the current mobile's dimensions, and we can use a percentage to figure out what the width of this screen and what the height of the screen should be when the app is running on that particular device. Keyboard avoiding view is another good component. When a user is typing text into a text input box, the keyboard can pop up and accidentally hide the input box. So we can use this keyboard avoiding view to push the text input box up and allow us to see the text input box and the keyboard at the same time. Linking is another component which we can use to link a general interface, both incoming and outgoing app links. Then we have the modal. Modal is a type of screen which comes on top of the existing screen, and it can show the different components. Pixel ratio, it provides access to the device, pixel and density. Refresh control, so this component is used inside a scroll view to add a pull to refresh functionality. Then we have a status bar. It's a component used to control the app status bar. Now, apart from these components, there are a lot of libraries available made by the community, which you can use in your mobile application. For example, let's say if you want to use navigation. Navigation is when you go from one screen to another. So there is a component called React Navigation, which can be used inside the app. To provide camera functionality, you could use the React Native Camera library. Similarly, there is a component, a React Native Map, which you can use to show a map to the user or can track the location of a user. We can add a QR scanner as well. So there are a lot of libraries available which can be used to provide different functionality to the app. Now, before we jump to the code, let's understand one more concept. So how do we create the JavaScript file? We create a .js file, which is a JavaScript file, where we are going to write all the components. Inside the file, we import the components that we are going to use. To demonstrate, let's say we are going to use a view, a text box, image. We will import those components from the specific library which provides those components. Then we'll create a class or a function, and then our JS file is ready. Now let's understand the difference between a class and a function. When we are writing a JS file, we can write a class or a function. Our class has a constructor where we can define the initial properties of the class. Then the class extends the React Native component or a pure component. A class has at least a render method. You can add more methods, but it should have a render method. The render method renders the UI of the screen to the user. Then there is a function, which is a plain JavaScript function. It has arguments called props, and it has a return value which returns a React element. So this brings us to the end of the video. In the next video, we'll see how we can plan the application. Thank you for watching, and I'll see you in the next video. Take care. Hello everyone, welcome back. In this video, we'll see how we can set up a new project. But before that, let's look at the basic project that we get when we run the project init command. So this is my project folder, and these are the default files and folders that we get when we create a project for the first time. So let's quickly take a look at these files and folders. Now at the top here, we have a folder which contains the test files. Beneath those, we have the Android project that we can open in the Android Studio. Then similarly, we have an iOS project that we can open in Xcode. Then we have package.json. Now, package.json has a name, the project name, the version number of the project, and these scripts that you can run. So for example, when we have to execute or run the app on the simulator or your mobile phone, you see React-native, run-android, and similarly for iOS. These are the libraries that the project is using. So by default, it is React and React Native, and their versions are 16.13.1 and 0.63.2. And then the libraries that this project is using. So these are the default libraries that come with the project. So as you install more libraries, they will appear here with their version numbers. Now the node modules contain all the libraries that you install. These are the ones which come by default, but if you install anything, it will go and sit in the node modules folder. Now the gateway to our app is the index.js. These are the comments. These three lines are loading or importing the components from the library. So the first one is the app registry. The second, here we have an app.js file. So we're loading the app.js file with the name app. So app becomes my component. Now app.json has the name of the project. So let's look at the app.json file. Here we see it has the name of the project, the display name, and just the name. And what we're seeing here is that this says import name as app name. So the app name is a variable from this file. And here in the last line, what we are doing is we are loading the app component or registering this component. And this component is app. So the index calls the app.js and the various listeners that you want to set up for your mobile application. Or if you want to write the navigation components, you can do that in the app.js. So if we scroll to the top, here we have the comments, and then here we can see that it's loading the components from the libraries. And then here it is building a function. So this block of code here is what builds the static page that runs and displays when we use the Android or iOS simulators. We'll look at each of these lines of code in more depth as we go through the tutorial. And here we can see that this is the style sheet that defines how everything looks, how the scroll view is displayed, the background colors, etc. We've got the font size, the margin size, the colors, all of that is covered in here. Finally, we have an export function here, which means that when we run, it compiles everything into a component, and this component comprises of the style sheet and the various components which we have loaded from the style libraries. Now we're going to have a look at the basic folder structure we get when we run our project init command. Now it's very important that you organize your files into specific and different folders. So what I do is whenever I create a specific project, I create specific folders to hold and contain specific files. Now these folders and folder names will vary depending on the specific project and app you're building, but for this demonstration, let's use a very simple example. So ordinarily, I would separate my files into two folders, one for components and one for containers. So two separate folders, components and containers. Now containers are the screens that we create for our specific apps, so all of those can go inside the containers folder. Now containers can further be divided, so for example, you could create a home folder. So we create a home folder and move that into the containers app, and depending on the different needs and requirements of the app that we're working on, we might have different container folders. So show map, for example. Or we can have a book ticket page. So whatever screens that we're going to create, we can keep them in our containers folder. And for components, we can create, for example, a login component, a registration component, and the different components that we need can all go into the components folder. Now, another thing that you should do is that you should have a common folder where you can keep the common components or the common functions. Now, another folder which I think is important to create is the themes folder. And this folder contains everything that has to do with the different layouts and themes and customizations of the app. So the different colors or the different fonts, all those sorts of things belong in the themes folder. This will be very helpful if you decide to change the themes and colors and margins for your app. So you just change the settings in one place and it will reflect on all the other screens in the app. Now another folder I like to create is the images folder. This is where we keep all the images used on the app. And then the fonts folder. So if you're using custom fonts, you can keep the custom font files in this fonts folder. So this is the very basic folder structure that I follow. Again, it depends on the kind of app that you're building. So you might have different folders, more folders, less folders, and that will guide you to what kind of folders that you may need. The idea and best practice is to set up your project folder so that all the files which have a common element, so all the images or all the containers, all the themes, are all together in one simple folder. So it's easy to navigate to that folder and change whatever it is that you need to change whenever you need to change it. And that is generally the best way to keep everything organized and easily findable and accessible. So thank you very much. This brings us to the end of this video on setting up a new project. In the next video, we're going to discuss everything about planning our app. So I will see you in the next video. Thank you for watching and take care. Hello everyone, welcome back. In this video, we'll discuss how we can plan our application. Now, the very first thing you need to do when building an app is get clear on what needs to be developed. You need to list the functionalities that will be required, and then you need to create the scope of your application. We'll discuss the scope and requirements in some of the different modules. Then, based on the requirements and the scope of the project, we can then determine how much effort will need to be put into the app, how much time and how many resources, and then we can determine how many team members, or if we need any team members, to carry on developing that app. Next thing you'll want to determine is which libraries your app will need. So which libraries are good, which libraries provide the necessary and required functions, whether it's a camera, QR scanner, those sorts of things. Then you'll want to choose your color scheme and font type, font size, etc. Then you'll want to determine what services your application will be using. So what push notifications will it use, which services will it use for those notifications, what kind of map it will use, what kind of SMS service it will use, those sorts of things. And then a very important part of app development, error handling. The errors should be handled in every screen, and in JavaScript you can use the code try catch block. And if there is an unhandled error, which should be caught in the global error handler, and that means that users will not see a crash screen when using the app. And then, once an error is caught, what course of action should be taken by the app? So does it log the error? Does it record an entry in the error database? This will allow you to figure out why the error came up and then take the necessary steps to fixing that error. Network info. So sometimes if the network is unavailable, it should display a message to the user letting them know that the network is unavailable. And because certain APIs require the network and retrieve certain data from the network, when the network is unavailable, those APIs can crash. So you'll want to implement some sort of system to make sure that even when the network is unavailable, it doesn't crash the app and the user doesn't have to see an error screen. Then you'll want to plan your project structure. So as we discussed in the last video, it's a good idea to organize your project into certain folder layouts, certain file layouts, making sure everything is organized and easily accessible. Everything is in a certain place so you can easily change or easily find things. And if you're in a team which has multiple users working on the same project, everybody knows where everything is. Next, we have app design. So there are a lot of different tools available to design an app. You'll want to determine which is the best tool for you and your project team. And then there are tools for designing, developing, and testing. Now, testing is an extremely important part of the app development process. Usually, I've seen developers don't give as much importance to testing as they ought to. It's a very important part of testing. It's the best way to avoid issues, figure out what's wrong with the app, and fix those errors before they show up in the end user's experience. Now, ideally, the development of this app is broken into development milestones. And at the completion of each of these development milestones, there should be a proper integration testing. This is important so that every new stage in the app's development is carefully tested and evaluated. Finally, we have the ad hoc releases. Now, at the completion of every milestone, or even between the milestones, you can have your ad hoc releases. Basically, an ad hoc release is the developer saying that we've tested this code and it works fine. We're not going to change what we've done so far unless there is a significant reason or a change request to do so. Also, ad hoc releases are properly tested. Now, for Android devices, this is very easy. You can create a signed APK and install that on the Android device. For iOS devices, it's a slightly more complicated process, but the principle still applies. you create the install file, and then you can test that on your iOS device and release it as an ad hoc release. So this brings us to the end of this video. Thank you for watching. I hope you found it useful. In the next video, we'll see how we can work with the core components of React Native. Thank you very much for watching. Take care, and I'll see you in the next video. Hello everyone, welcome back. In this video, we'll see how we can work with the core components of React Native. So let's jump to the coding editor. So this is the app.js file that is created after we run the project init command. So this is what we'll be working with for this demonstration. I've removed the hard-coded text that we saw in the previous videos. Now I'm going to import a component called component from React, and our class will be extending this component. So we'll create a class. To do that, I will create class export, default, class, and my class name is app, extends, component. So this is my class signature. Now the first thing I'll add is constructor. So constructor, and in the constructor, the first thing I'll do is I'll call the super function of the constructor to load all the props that have been sent to this app. Okay, then I can define my state of this app. So the initial state variables I can define here. So let's say txt, username, for now, let's just have one variable. So now we have the constructor, and in a class, the bare minimum that it should have is a render function. The render function renders the screen on the mobile phone or device. Now let's define. So we have a view, and inside the view we have text which says, hello, this is my first app. Now this will appear on the mobile screen. Now in order to render it, I actually have to use the keyword return. So return inside a bracket. So I'm returning render function will be called. Render function contains my view text. So let me save this. And I have already started my iOS simulator. So let's go have a look at that. So now if you look at the top left corner, just above the time, you can see that the text that we just typed in to display is hiding up there. Let's change the code to make this a bit more visible. We will use the styling options that initially came with this app.js file. So there is a style called section container. So let's change this view here by typing style equal to, and then in the brackets, styles dot this section container. So I'm using Visual Studio Code, and it's a very good editor. It'll tell you what styles are available, what functions are available, etc. And if you have any variables, it will tell you which variables you can use. So let me save. And going back to the simulator, we can see that it has put the text in the top margin, and it has brought our text a little bit below the top left corner. Still, this doesn't look how we want it to look, so let's go back to the editor. And now we'll do two things. We will increase the top margin. So let's make it 60. Now this hard coding of the margin or the font size is not encouraged, it's not recommended. So we'll see how we can correct this later on. We'll use a section title to display the text. So just here next to text, we will add style equal to styles.section title. And let's see how it looks now. There we go. We can see it's looking a lot more presentable. It's a lot easier to see, a lot more visible. So we've used a view container that has text within it. Now another code component that we usually use is image. So first we will import the image component from React Native, and then we will add an image here. So we type image and it has a property called source, and source equal to, and in the brackets we put require, and then we give the full path of the image. So I have an image in my project folder, in the folder called images. We've got this image here, which is image_user. So we go to our code and we type in the ID string. So it's inside the project folder where my app.js is. So I'll say ./images/img_user.png. You need to give the full name of the file and the path. And we'll close the image tag. Now let's save. And we can see that it is displaying the image right underneath the text. Let's bring the image a little bit lower on the page. So image also has a style property. So we'll type style equals symbol, styles dot user image. Now let's see if there's already an image style down here. It's not there, so let's create this style. We'll call it user image. To do this, we'll put the name user image here. Then we'll use a colon and a bracket. After the bracket, there should be a comma to have another style underneath it. So in order to bring this image down, we will add a margin top. Now there's different margins. There's margin bottom, margin end, margin horizontal, different ones. But for this one, we are going to use a margin top. And we will use a number. The number we'll start with is 10. And then we'll create a margin left as well. And give another number 10. And now let's see how our image looks. So we can see that the image has shifted slightly, but we want a greater change in the image position. So let's go back to the editor. Let me change this to 30. And we can see it shifted it down quite a bit more now. So this is how we can design our app using this editor. It's a bit of trial and error, but when you get the numbers as you want them, it works quite well. For now, let's have a look at another component, which will be text input. Now, text input is a component which is used to take text inputs from the user. This function comes from the React Native library. We put a comma after it. And one of the great things about this editor is that if I put the text input without the comma after it, the editor will alert me to the fact that it is missing a comma and the code is not going to work correctly. So if I put a comma after, there's no error and the code will work correctly. Now, text input has more properties that we can use. So let's type in text input here. And so the first thing that we need is the placeholder. Now, the placeholder is the first thing that you see when you see the text input, and it tells you that this is what you have to add to the input box. So for example, enter username. Now, if we go back to the simulator, we can see that this input box is tucked away underneath the image. So let's put this input box in a view. And let's copy the section container style. Paste it and change the name to input view. This new input view style has a margin top at 60 and a padding horizontal at 24. Let's keep those values for now. Scroll up and change the text input style to style equals styles dot input view. So let's save this and check what it looks like in the simulator. And as we can see, it is pushed the input box a little bit further below the image. So let's copy these variables from the section title, the font size, the font height, and the font color. Let's paste them in input view and see how it looks like from there. So with these changes added to the input view style, we can see that the text looks much better. And this brings us to the end of the Working with the Core Components video. Thank you very much. In the next and last video of this section, we will talk about what we learned in this section, and then I will share a challenge with you. So I hope you found this useful. Thank you very much, and I will see you in the next video. Hello everyone, welcome back. This is the last video of this section in which I will summarize everything we have learned so far. We started this section by discussing the React Native components that come with the React Native default installation and the community components. So we had a view, text, image, text input components, scroll view, etc. Then we had some community components. So we had the camera, the QR code components, the map components, navigation, etc. Then we saw how to set up a new project in React Native. So we saw the basic project folder and files, the layout when we've done the project init command, and then we created a folder structure so we could organize the different files and folders and make sure everything was easy to navigate to. Then we discussed the planning the app stage. This is the very important stage which comes before you start designing and coding your app. Next, we discussed working with the core components, and we created a very small and very simple landing page where we showed the title, we added an image to that title and an input box, and we changed the style features of those various elements. So now on to the challenge I want to share with you. So in this challenge, I want you to create an app or modify your app.js that you already have when you build your new project. And then I want you to add a title, an image, and a text input box. And I want you to play around with these a bit. So you can play around with the color of the title. You can change the view settings so things are laid out in a certain way. You can change the margins and things. If you want to put certain text, the example text into the input box, if you want to change that as well, that's what I want you to do with this challenge. And just have a play around and get a feel for how these different components work and how you can change them around to suit your design needs. Finally, I want you to add a feature to this landing page that the title of the landing page changes according to what the user enters into the input box. So an input box gives the user the opportunity to type in a string of text, and when the user has typed in that string of text, the title of the landing page changes accordingly. Now, this is a feature I have not demonstrated for you in these video tutorials, but if you just have a look at the text input and try and figure it out, that's the challenge. There's a way you can make it so whatever the user enters into this text box changes what the title of the landing page will be. So thank you very much for listening. Best of luck with this challenge, and I look forward to seeing you in the remaining sections of this video tutorial series. Thank you very much. Take care.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.